Hey there. If you're starting with Python, it's a very good idea to have a strong grasp on basic data types and data structures before going over more advanced topics. For this video, I am using Jupyter Labs, and I will leave a link in the description in case you're interested in setting that up for yourself. So in the first cell, I have a equals 1, which is an integer, and then on the second line, I have b equals 1.5, which is a float. So as you can tell, the difference between floats and integers is that floats have a certain number of decimals after the whole number. We also have this type called complex type, and if this notation doesn't look very familiar to you, don't worry much about it. It's not a very commonly used data type, but it is available to you in case you're working in a math-specific domain. So this is just a representation of complex math numbers. We also have the string type. So in some languages, you may have heard of characters versus strings. In Python, we only have the type string, whether you have a single character or a series of characters. We also have the Boolean type, which can only be true or false. The next one is none, which is of none type, and that's the only value that you can have for that one. I also want to mention the byte type. So in Python, you can have a series of, for example, integers or characters and represent those as a series of bytes. So in this case, A is a byte, B is a byte, C is a byte, and in case you're not familiar, a byte is 8 bits. Going deeper into bytes is a little bit beyond the scope of this video, but I might create a separate video on those. So let's run this cell. And let's use the built-in function called type, which basically just tells you what is the type of a variable. So as we expect, A is of type integer, B is a float, and instead of writing this over and over, I'm just going to use a list comprehension, which is just a for loop that goes over all the variables that I have up there and print out every type that I have. So if you try to check these, you will see that they are exactly the same as what I have up here. Now, one thing I want you to notice is that if you try to print type, you will see something like this. So this is exactly the same as this int up here. So these are not strings. These are actually the classes that are being printed out. The reason I mention this is for when you want to do type equality check, and we're going to talk about it in a second, you will need to basically write these classes as opposed to something like this. Now, what is the point of knowing the data type of certain variables that we're using? So for every variable, we have a certain number of functionalities. For example, you can add numbers, but you can't add a number to a string. So if I try to add A and B, I get 2.5, that's expected. But if I try to add A to S, then Python tells me, this functionality is not supported for a string. Let's switch that one back. But for example, for a string, I can switch a string here. I have ABC to uppercase. So we have this, nice upper function available to us, and we can do that. But for an integer, that would not make sense. So we see an error. Let's switch that one back too. Now, there are a very large number of functionalities for each type to kind of make your life easier. And when you know what type something is, then you can leverage those functionalities and use them, in your code. Now, let's talk about type equality. So let's first do an equality check to integer. So 2 is of type integer. So for this, I will see that, that is the case, that is true. And the second option that I have is I can use the isInstance method. That's also a built-in method. So if I do a isInstance of int, I also see that's true. There is a subtle difference between type and isInstance, and that's regarding checking classes and subclasses. So if I use object, which is the parent class to all classes in Python, then again I see true down here. But if I switch this one back to object, then I see false, because type only basically, we are doing a type equality if this is exactly the same type, as opposed to isInstance checks if this argument that we have is of type int or parent of int or parent of int. Basically, it looks at all the classes that this argument could inherit from. So that's a subtle difference. If it doesn't make sense right now, don't worry too much about it. Maybe as you learn more about classes in Python, this will make more sense. The last thing I want to talk about in this video is type conversion. So you can convert different types to other types. For example, using the keyword pretty much for all of them is exactly the name that we had up here. So int, float, bool, string, these are exactly the functions that you would use to convert something to something else. For example, for Boolean, 0 would give us false, all other numbers would give us true. So that's a conversion. So even if you have a negative number, that would be converted to true if you try to convert into Boolean. For integers, like for example, I can change a float to an integer, and what int does, it basically just slashes any decimal that comes after that. So if I have positive 2.9, then I get 2. Float does exactly what you think it does. It changes an integer or anything that I have. So if I had a float, it would just do nothing. It would just return that float. String changes anything that you give it to a string, and bytes, which is something I use up there, it changes this series that I have into a series of bytes. And if this notation doesn't make a whole lot of sense, don't worry too much about it for now. As far as you know that we are doing type conversion here, you should be good as far as basic data types are concerned. I hope this video helped you kind of get a quick glimpse on what Python has available as far as basic data types go. In the next video, I will cover some data structures like dictionaries, sets, frozen sets, and I think this will give you a very good foundation for more advanced topics in Python. As always, thank you so much for watching, and I will see you soon.